Hi guys, welcome back to the channel, and you're with me Arun Sharma, and this is Quants question of the day. As promised, Tuesdays, Thursdays, Saturdays is when I'm doing these sessions for you, these questions for you, and they'll come either in the live format or in a recorded format in case I'm not able to go live on these days. And I hope you're enjoying this series and parallelly also enjoying the verbal series, and we are trying to think of more series which can actually give you concrete ideas and concrete evidence of what we want, and concrete learning of what we want to actually deliver to you through the channel. So please do like the channel, do subscribe the channel, please do share the videos, help us grow faster so that we can bring more such fantastic products for you. So the question that I'm picking up today is a question which appeared in CAT 2020, and it's an interesting question because this is a question type which asks you to actually find the area enclosed by a group of graphs. Now, whenever you see an area enclosed questions are very common in CAT and also in all other exams. Area enclosed by graphs is a very common aptitude question. CAT mein aata hai, it comes in XAT, it comes in a lot of other aptitude exams, or you never know when the other exams which keep following CAT will start going into these directions. And area enclosed questions जो होते हैं उसमें essentially the solution of area enclosed questions based on being able to identify a clear structure for the area that is getting built on a graphical situation. So graph plotting becomes important. So let's have a look at this question. What does this question say? So the question is saying the area of the region satisfying the inequalities mod x minus y less than equal to 1, y greater than equal to 0, and y less than equal to 1. So we are talking about three inequalities: mod x minus y less than equal to 1, y greater than equal to 0, and y less than equal to 1. The question is asking us the area of the region satisfying these three inequalities. So how do you think inside these questions? Inside these questions, basically the thinking pattern or the thinking process, and you're playing for 3 marks in an exam like CAT 20 here when you're doing this. So inside the question, when you start thinking, the triggers basically are what graphs there are, and essentially, as I told you, whenever there's an area enclosed question in a situation like this, or based on functions or based on inequalities, you'll always form a closed area. There'll always be some kind of box being made. So the idea is to build that box, or the challenge is to be able to build that box, build that closed area on the graph, on the xy axis. So there are three inequalities here that are defining the regions that I want to look at. So if I start looking for these inequalities, y greater than 0, greater than equal to 0 basically means if this is my x-axis, you know the x-axis is y equals 0. The x-axis is defined as y equals 0, and anything on top of that, anything to the vertically above that, will basically be the area which will be created. And this is an infinite area because of course the x-axis is an infinite line, and anything above that is y greater than equal to 0. The upper side but here is defined by y less than equal to 1. So if I look at y less than equal to 1 here, the second graph or the second inequality given to me, that's also pretty easy to understand that the second line here, y less than equal to 1, y is equal to 1 is this line. I mean, I'm sorry about the waviness of my lines, but I hope you can understand this. Y is equal to 1 is this line. So y less than equal to 1, when you have this trigger that y is less than equal to 1, we are talking about everything below this line. So if I look at these two lines together, we are trying to create, we are getting a band which is an infinite band which looks something like this, and this band continues from plus infinity to minus infinity. So the area of this band actually is infinite. If there are only two inequalities given to me, y greater than equal to 0 and y less than equal to 1, the area I'm getting for that would be actually infinite here. So what do I do next? What I have to do next is essentially, let me just clean this up. What I need to do next is essentially try to see how the third inequality creates an area that can be measured, or creates a box that can be measured. So when I think of the inequality mod x minus y less than equal to 1, the best way to think about it is, don't think about mod x minus y less than equal to 1. Think about it this way. Think about the inequality mod x minus y is equal to 1, and at various values of x, at various values of x, you can start thinking about what values of y will come for this equality, right? So if I think about the y-axis, the x-axis, already thought about. If I think about the y-axis like this, then this is the point 0, 0, because this black line is my x-axis. So this is the point 0, 0. So at this point, the value of x is 0. And if the value of x is 0, I can start plotting the value of minus y such that this becomes 1. So the value of minus y has to be plus 1, which means that the value of y has to be minus 1 in this particular case. So I get a point which is 0 and minus 1. That means x is 0 and y is minus 1, which satisfies this inequality, satisfies this equation, right? So at x equals 0, y equals minus 1, I have equality for this equation. Now I need to think about more such points. So if I take a value, for example, if I take mod x to be plus 1, and you have to imagine these graphs by thinking on the spot, by taking a few values, and as you know, this will be a linear graph mainly, but you will have to find 2-3 points before you can start talking about the linearity of the graph. So you can see that when mod x is 1, mod x can be 1 in two cases here. Mod x can be 1 for x is equal to 1 or x is equal to minus 1. Mod x can be 1 for x is equal to 1 and x equals minus 1. And all this thinking you have to do inside the exam. So when x is 1, I want mod x minus y to be 1. So if mod x is 1, my value of y has to be 0. Only then do I get this equal to 1. So that means I have another point that at x equals 1, my y is 0, and at x equals minus 1 also, the value of y is 0. So I get 2 points here, which will be part of a graph or a function which gets defined by this expression. And of course I know that this is a linear expression because mod x is linear and y is also linear. So I can visualize that there will be a straight line connecting this. So if I want to think further, what is going to happen is I can start thinking about what happens to x in case, and you can confirm the straight line before if you want to. If you want to confirm the straight line, just take the value of x as 0.5. You will see that y is minus 0.5 for that. If I take x as 0.5, if I take x here as 0.5, the value of y will come out as minus 0.5 for this to be equal to 1, and that confirms that at 0, minus 1 and 1, 0, at 0.5 it's minus 0.5, so it confirms that there's a straight line here. Does the straight line go ahead? So I can keep going. That what happens, now I should be able to see that because the constraint, I mean ऐसे तो इस equation का तो infinite solutions आ जाएगा, because by default this is two unknowns, one equation, so it has infinite solutions. But we know in this question, from the earlier two inequalities that were given to us, that the value of y is constrained to be between 0 to 1. So all this area that we are getting here is not going to be part of my graph. So I should now realize that since the maximum value of y that I can take, the maximum value of y I can take is 1, maximum value of y I can take is 1. So for this equality to be equal to 1, the maximum value of x I can take is 2. or I can go to the other extreme of minus 2. So when I take x as 2, 2 minus 1 gives me 1. That means this line will extend to the point x2 and y1 on this side, and on that side this will again extend to the point minus 2 and 1, because if I take x as minus 2, so this mod x will be plus 2 and y has to be 1, so that minus 2 minus 1, 2 minus 1 gives me 1. So this blue line that you see, this V-shaped blue line that you see, is basically the construct of the equation mod x minus y equals 1, or the function mod x minus y equals 1. That's the construct of this. Now, what you also need to confirm is that then what is the constraints when you say mod x minus y less than equal to 1? Is it going to be above this, or is it going to be below this? Now instinctively you realize that it has to be above it, because only then will you be able to get a closed area between these three lines, and you can find the area enclosed by that box, because intuitively if this is the area in which mod x minus y is less than equal to 1, then you're not getting closed area, because तुम्हारा जो band था for y greater than equal to 0 and y less than equal to 1, that band was above here. So this function and this inequality and the area of this inequality has to somehow intersect that band. So intuitively you can find that out, or you can understand that. But if you want to check that, the way to check it is, suppose I go for this point at x equals 0. If I go for y below minus 1, for x is equal to 0, let me take a cleaner sheet. We know that x is equal to 0 पे y का value minus 1 लिया था, तभी ये 1 आया था. That much we know. So if I take this value of y below minus 1, suppose I take this value of y as minus 1.1, so you can see that this expression becomes 1.1, and mod x minus y, when you compare this function with mod x minus y is less than equal to 1, a value like minus 1.1 does not satisfy it. But on the other hand, if I take the value of y as minus 0.9, then you can see that 0 minus 0.9 will give me a value which is 0.9, which will obey this function, which basically means that what we are seeing counterintuitively here in this graph, that essentially the area that is represented by mod x minus y less than equal to 1 is basically opening upwards. And of course, please understand, mod x minus y equals 1 will continue all the way, because you can take x as 5 and y will be 4. So you can have that infinitely, but we are only bothered about this area, which is the intersection of these three areas. We are only bothered about this area, which is the closed box that is formed in the intersection of these areas. So when I now want to find, once I have identified this area, I want to find out the value of this region in terms of area enclosed. So this is a triangle. This is a triangle which is going from minus 1, 0 to minus 2, 1. So which means it has a height of 1 and a base of 1. So this area is 0.5. On this side, you have a similar triangle, same triangle actually, height of 1 and base of 1. So this is also an area of 0.5. So 0.5 इधर हो गया, 0.5 वहाँ पे हो गया. And then you have this area, this rectangle, which is a base of 2 and a height of 1. So इस rectangle का area 2 है. So the total area is 2 plus 0.5 plus 0.5, which is 3. So the correct answer to this question is 3. It was a theta question, and this was the answer to this question. So do comment about how you found this video, and how you're finding this series, and we would love to bring more things for you. Do comment about what else you want. Some of you have been asking for DILR. We plan to start something for that also, for the YouTube audience. And please share the videos, and I'll see you again with the next video on this series on Thursday. Please look out for that. Bye bye. On Saturday, sorry. Please look out for that. Bye bye.